The coded telegram from Hard Rock Bill Smith could not have been clearer. There was precious metal in that ground. So Fred McLeod and Arthur Cockshott went to work, staking 15 claims all the way from the south arm of Kenogamisus Lake to the west arm now called Barton Bay. That was in 1931. By the spring of 1934, men were going underground at the McLeod-Cockshott mine just on the outskirts of what was to become Geraldton, Ontario. The old entrance to the mine, the headframe, still looms over the highway, across from the discovered Geraldton Interpretive Center. It took years of sweat and toil, but the mine yielded more than 1.5 million ounces of gold and 108,000 ounces of silver. Finding the gold was one thing, but freeing it from the rock was a whole other matter. Large chunks of ore were pulled from the ground and smashed, making the pieces smaller and smaller. First, the ore was reduced to half-inch chunks. Then, the ore moved on, taken away in bins. It was mixed with water and ground down in powerful mills. A typical mill consists of a large rotating tube loaded with steel balls or rods that help crush the ore into smaller particles. The mills reduced the ore to pieces only slightly bigger than the head of a pin. That pulp of ore and water was then ready for the next phase, flotation. The magic of flotation is brought about by mixing reagents and air with the pulp. The reaction causes particles containing gold to float to the surface, forming a golden froth. That froth, essentially a gold concentrate, is scooped off. Of the 1,900 tons of material taken from the ground each day, only a mere 130 tons, less than 7%, would float to the surface of the froth. But the system was stunningly effective, recovering 94% of the gold trapped in the ore. As for the remaining 1,770 tons of ore, that was waste, or tailings, and was pumped to low-lying areas on the property. The gold concentrate was settled in large tanks called thickeners. But the effort to free the gold from the rock did not end there. Once thickened, the golden soup was pulverized again, ground down in a secondary mill. The soup was moved to agitation tanks and cyanide added to dissolve the gold, a process that would help separate the gold from the rock. Finally, the gold was separated from the rest of the ore through a combination of filtration and simply letting the solid particles settle to the bottom of the tanks. The solid remnants were then discarded as tailings. The gold then had to be stripped from the solution in a process called precipitation. Precipitation involves adding zinc and a small amount of lead to the gold soup. An electrochemical reaction between the metals in the soup causes the gold and the small amount of the zinc to fall out of the solution. It takes a lot of zinc to free the gold. 30 pounds of zinc will precipitate just 150 ounces of gold. That's close to 10 pounds of gold to 30 pounds of zinc. The mixture of gold, zinc, and barren solution was sent through a filter press. When enough gold had accumulated, the press was opened and the precipitate removed. That cleared the way for the final process, refining. The precipitate contained about 30 to 50% gold, 3 to 5% silver, 10% water, and variable amounts of copper, zinc, sulfur, lead iron oxide, arsenic, lime, and silica. To separate it from the impurities, the gold and silver had to be melted. The precipitate was heated to 2,000 degrees Fahrenheit. The impurities formed a molten slag, which was poured off. The purified gold could now be poured into cast iron molds. The bars cooled, were removed from the mold, cleaned of any remaining slag, and sampled by drilling holes in the brick. Finally, the bounty of the McLeod-Cockshott mine was weighed, boxed, and shipped to the Royal Canadian Mint in Ottawa.